And right now, the NASA test director is briefing the launch team on the procedures. HASGAS will be closely monitoring sensors that are with the technicians for high concentrations of oxygen, hydrogen. And so there is a high degree of focus by the teams, especially the safety team, hazardous operations, currently getting ready to be underway in just a few minutes. Again, intermittent leak on the core stage, liquid hydrogen replenish valve. It's on a skid on the side of the mobile launcher. The red crew team has been mobilized. The plan to torque down bolts inside the ML where the valve has been briefed the launch director. It's been signed off on. And we're awaiting the departure of the red crew team out to the launch pad. Stand by for more updates. This is Artemis Launch Control. All right, Launch Director Charlie Blackwell Thompson just gave the go for the Red Crew team to enter Launch Complex 39B that you see there on your screen to work a issue with a leaky replenish valve on the side of the mobile launcher. The mobile launcher is the gray structure that you see there. The Red Crew team is highly trained group of individuals, 2 technicians and 1 safety lead that will be making entry into the pad to tighten down bolts, the packing bolts on the valve. It is a straightforward job as described to me by the launch team. Once they're at the valve location, the Red Crew has advised it should take about 15 minutes to do the work. So they should be in and out of there relatively quickly. There's no troubleshooting to be done. They have a specific task that they're going to go in there and perform. And then they'll depart the pad. It is a hazardous operation inside the blast danger area. And the launch team will be tracking their every movement. EMS is standing by, along with pad rescue. We'll keep you updated. This is Artemis Launch Control. Okay, you're looking at a live shot of the launch pad and the two vehicles at the bottom that just arrived, the two technicians, and the safety representative. This is the red crew that is specifically tasked to go out and tighten some bolts on the core stage hydrogen replenish valve on the side of the mobile launcher. It is a hazardous operation. But as you can see from this camera view, and I have view of the safety team here, they're monitoring multiple camera views and watching the red crew as they do their work. Looking to fix an intermittent leak that popped up about an hour ago. T-minus 2 hours and 13 minutes. We are tracking the red crew, 2 technicians and a safety representative that have made entry to the launch pad and are currently inside the compartment where the leaky replenish valve is. Again, the red crew, which is a specially trained crew to work in and around a fully tanked rocket, is inside the compartment area where the leaky replenish valve is. It's on the liquid hydrogen side. Their job is to torque down the bolts, the packing nuts on this particular valve, and that is, as I understand it from the launch team, currently in work. Safety team is watching on cameras that are in and around the launch pad. This is not a totally uncommon operation. The red crew, there's a number of individuals who stand by ready to do work on the red crew, who are specifically trained in their areas of expertise when they have to put hands on at the launch pad after or during tanking. So this is likely to eat into the launch window. An update on the tanks. We are in replenish on both the liquid oxygen core stage and upper stage. We are in stop flow for liquid hydrogen on the upper stage and the core stage. And that stop flow, of course, is related to the intermittent leak on the replenish valve that's on the side of the mobile launcher. We saw the red crew go in. The red crew estimates it'll take about 15 minutes to complete the job. And then they're coming right back out. This is Artemis Launch Control. T-minus 2 hours and 7 minutes and counting. We are currently tracking work done by the red crew, currently out at the launch pad, a specially trained crew, torquing down some bolts on a hydrogen replenish valve. The safety team has eyes on it. They're currently doing that work. I want to make a programming note for you. Currently, if you're watching NASA TV's main channel, we are now going to begin the special launch broadcast that we have planned. Meanwhile, over on the NASA television media channel, we will continue with operational commentary. Again, we're getting ready to start a launch broadcast, a special launch broadcast on the NASA TV main channel, but we will maintain operational commentary on NASA TV's media channel. Please stand by for that. This is Artemis Launch Control. Yeah, that's right, Megan. The launch director gave the go for tanking shortly after 3 p.m. this afternoon. But as of right now, there is a red crew, as they are named, a specially trained team of individuals out at the pad making an unplanned change to a replenish valve on the liquid hydrogen side. There are 2 technicians and a safety representative that are right now working inside the mobile launcher. It's in an open air area that has a replenish valve that goes to the liquid hydrogen side of the core stage. Now this happened roughly earlier this evening, probably about an hour ago, when a leak was detected at the core stage liquid hydrogen valve by the launch team here inside Firing Room 1 at the Launch Control Center. Unfortunately, the team here was unable to remedy the leak remotely, and so it became necessary to send a crew of individuals, called the Red Crew, out to the launch pad to make a hands-on fix, so to speak, to that valve. And what they're doing is they're torquing down bolts that are on the valve. They believe that by torquing these bolts down, they'll get a better seal on that replenish valve, and that should remedy the leak. The leak was detected by the hazardous operations team here inside the launch control when the percentage of hydrogen went above 1%. Now that's significant for this particular area because it is an open air location, the skid valve that runs the liquid hydrogen into the core stage. And we had reached replenish when this leak was detected. Over on the liquid hydrogen side, of course, there's 2 tanks on the core stage, liquid oxygen and liquid hydrogen. Both had been topped and gotten into replenish when this leak was detected. Currently, liquid oxygen is topped off and stable in replenish, but the liquid hydrogen is in stop flow at the moment, which will prevent them from proceeding forward with a launch until that leak is remedied. Again, this Red Crew is inside the area, inside the blast danger area, working inside the mobile launcher, torquing down those nuts that are associated with the replenish valve for the liquid hydrogen side of the core stage. Of course, we'll keep you updated on the operation. In the meantime, I'll send it back to Megan. Yeah, Megan, now continuing to track the Red Crew's work at the launch pad. This is a specially trained team of 3 individuals, 2 technicians, 1 safety representative, who are currently right now inside the mobile launcher at the base of the launch pad. They are doing work on a replenish valve, currently torquing down the bolts in order to remedy a leak in that replenish valve that was detected a little over an hour ago. Now, this is significant because currently with a leak, they have had to go into what's called stop flow on the liquid hydrogen tank of the core stage. Normally, under replenish, they continue to flow liquid hydrogen into the tank as it boils off in order to maintain a level of around 100%, but that has been in stop flow, and so at this moment we are slowly losing liquid hydrogen in the core stage hydrogen tank. The Red Crew went in and is currently working a little longer than expected on the issue. It was estimated that it would take 15 minutes to do the work, but as we're now finding out, the Red Crew is torquing down the bolts and then backing out of the area and allowing the launch team to cycle the valves to test to see if they've got that leak fixed. So as they do this, we understand they will cycle this work, go in, cycle the valves, torque them down again if it continues to leak, and then back out and test the work. And this may continue until they have it fixed. The Red Crew going onto the launch pad isn't a totally uncommon occurrence, certainly new with the Artemis program, but work like this was done in previous space programs. The Red Crew is specially trained for this work. They are accustomed to working around in hazardous operation, especially a fully tanked rocket. Again, we are tracking Red Crew's operation out at the pad. It's expected that this will eat into the launch window, which currently we have liftoff at 1:04 a.m. Eastern Time, but the window runs 2 hours to 3:04 a.m. Eastern Time. Again, monitoring the Red Crew's work. We'll have more updates for you a little later on. For now, back to you, Megan. T-minus 1 hour and 45 minutes and counting. We are currently watching work out at the launch pad alongside the mobile launcher, where a team of individuals is currently torquing down bolts associated with a liquid hydrogen replenish valve. The work is ongoing. The safety team is monitoring the Red Crew's work. Via live camera feeds. The work was signed off on by the launch director around 10 o'clock Eastern Time when an intermittent leak was detected on the hydrogen replenish valve to the core stage. We continue to track the progress here. We'll bring you updates as soon as they are available. Yeah, Megan, we just saw the red team give a thumbs up to the camera as they are doing their work out at the launch pad. Currently, they're torquing down some bolts to the specification required in order to try and stop what has been described as an intermittent hydrogen leak in the area. It went above the 1% threshold, and so that is a violation of the has-gas limit in that area. The team continuing to work. As you look at the rocket on the pad, they were called out to the pad about a half hour ago, and they appeared to be making their way, at least have stepped back from the area of work. The way that the workflow has been going is they torque down the bolts, step back a little bit. The launch team then cycles the valves to check to see if the leak is still there, and then they come back in, and this has happened a couple of times, and start torquing the bolts again. The rocket was nearly fully tanked. The core stage was in replenish for both hydrogen and oxygen. The upper stage had nearly been finished when the leak was detected, and the countdown, though it is continuing, the rocket, the leak had to be addressed in order for the launch to proceed. The replenish puts the hydrogen back into the tank after it boils off, and so currently we're in a stop flow which no longer allows a replenishment of the hydrogen tank, and that would not allow us to have a launch without those tanks being in total replenish, and also in a vented configuration, which has also been put on hold. I'm sorry, not a vented configuration, but rather an engine bleed has been stopped. And so that would need to continue as well in order to get the engines conditioned for launch. That's the latest here from Firing Room 1 at the Launch Control Center. Megan, we'll send it back to you. Okay. See if they got movement. So the valve's not moving, the valve's like frozen, or? Oh, so the nuts were loose, like visibly loose. But, okay, all right. Okay, so copy that. Thank you. Thank you. Are they done? T-minus 1 hour and 38 minutes and counting. We have an update now. Again, an update from Launch Complex 39B. The red crew has completed their work at the pad, tightening down some bolts that seal a liquid hydrogen replenish valve on the side of the mobile launcher. I want to correct something that I said earlier, and that is that they are not leak checking it in between torquing the bolts. They are just cycling the valve in between torquing the bolts to make sure that the bolts are secure. Again, the work that happened was tightening down the bolts on a leaky replenish valve on the liquid hydrogen side that feeds the core stage. And they cycled that repair, cycled the torquing of the bolts as the launch team cycled the valves. The work is complete, and the red team is on their way out of the pad. They're specially trained to work inside the blast danger area. There are 2 technicians and 1 safety representative now headed out of the mobile launcher. This is Artemis Launch Control. update on the operation out at the pad. The work is complete and the red crew has departed the BDA. Again, the red crew that was out at the pad torquing down the bolts to a leaky core stage hydrogen replenish valve has been complete, and the red crew has departed the blast danger area. The team will now start checking the valves, that hydrogen valve, to determine if the leak has been fixed. A discussion will now take place on what to do about the requirement for a 90-minute engine bleed with liquid hydrogen. That was interrupted when the core stage replenish went into stop flow as a result of the hydrogen leak. Again, a discussion about how to manage the 90-minute bleed will be happening, and we'll give you the latest on that in a moment. For the meantime, we're at L-1 hour and 28 minutes and counting. This is Artemis Launch Control. Yeah, that's right, Megan. We're inside the firing room number 1 here at the Launch Control Center at the Kennedy Space Center. And currently we have an update on that red crew, which went out to the pad to torque down some bolts on a leaky hydrogen replenish valve for the core stage. And that update is that the red crew has departed the blast danger area. They have completed their work. They got the go at 10 p.m. this evening, 10 p.m. Eastern Time, to go out and conduct work that took roughly an hour from the time they were given the go till the time they left the blast danger area. The technicians, 2 technicians and 1 safety representative, did the work out at the pad on the replenish valve. And now that they are on their way back, the team is now examining the work and whether or not that leak is still there. What we do know is, you may have heard me mention that this put the liquid hydrogen tank into stop flow, and as a result also stopped a required 90-minute engine bleed for the liquid hydrogen side. Teams have come to the conclusion that only a 45-minute bleed is required at this point. They can resume the bleed at the point that they left off, and it'll be enough to meet that requirement for launch. You're looking now at a graphic where we're tracking the core stage fill rate. We did this earlier this evening. Took about 4 hours and 20 minutes to fill the core stage. You can see on the left that the core stage liquid oxygen is at 100%. That's the same for the upper stage, and both are in stable replenish. As you can look to the right, though, you can see that we're at 97% for liquid hydrogen. The reason for that is because when we went into stop flow, that means that the replenish was no longer refilling the tank, and that liquid hydrogen was boiling off and draining some of the capacity out of that particular tank. So we've lost some liquid hydrogen. The plan is to resume, of course, the filling of liquid hydrogen, which goes into that into the liquid hydrogen tank on the core stage and then vents out on that flare stack that you see to the right, where excess hydrogen is burned off. That's the latest here from Firing Room 1. Megan, we'll send it back to you. minus 1 hour and 13 minutes. The range has just advised the NASA test director that one of their assets required for launch is down. And so at the moment, the range is no go due to a lost signal on their radar site. Again, the range has advised the NASA test director that one of their assets required for launch is down. And so as a result, the range is no go at this moment due to lost signal on their radar site. The range is working on the issue. NASA test director has asked the range to keep them updated. And we'll do the same. This is Artemis Launch Control. Update on the core stage liquid hydrogen replenish valve. Work is complete. Red Crew team is back. And we have resumed flow into the core stage LH2 tank. Again, we have resumed flow into the core stage LH2 tank. Meanwhile, the team is working to get the upper stage liquid hydrogen configured to resume the fueling operation on that part of the rocket. Stand by for more updates. This is Artemis Launch Control. Yeah, thanks, Megan. And so we get an update for you now. The red crew, of course, completed its work on torquing down the bolts for that replenish valve on the core stage hydrogen side. And now we are back in replenish for core stage hydrogen, which is good news. The team now looking to work on that upper stage, and we understand for the update to the NASA test director, they just informed the NTD that they can start getting back the flow on the upper stage as well. It went into a stop flow roughly around 10 p.m. Eastern time after a leak was detected. You can see the core stage status there. Liquid oxygen side is in stable replenish, both for the core stage and the upper stage of the rocket. Over on the right side, you can see we've lost some hydrogen since going into a stop flow that allowed some liquid hydrogen to boil off during about an hour or so while a red crew was sent out to the launch pad to make repairs. Now, the hydrogen bleed for the engines was reestablished, and it looks like the team is back on track to recover that after a stop flow halted the bleed. They are required to bleed that liquid hydrogen through the RS-25 engines for 90 minutes, but they're picking up where they left off, and that appears to be on track. In the meantime, we've had an update from the range, and the range has informed the NASA test director that currently at the moment, if we were to launch now, they are no-go due to the loss of signal on a radar site. That's currently being worked right now. Again, the range advising the NASA test director that they are no-go. The range is not clear for launch until they remedy that issue on their radar site. And so we're also tracking that. In the meantime, we started this at 3:23 p.m. Eastern Time. Got the core stage tanked in about 4 hours and 23 minutes, and now looking to get everything back on track to try to make that launch window at 1:04 a.m. Eastern Time, which has a 2-hour window associated with it, all the way to 3 a.m. Eastern Time. That's the latest from the firing room. Megan, back to you. T-minus 56 minutes and counting. We have an update now on the range. Stand by. The range is updating the NASA test director at the moment. Again. Okay, we're back in core stage topping for liquid hydrogen. Fast fill is complete. Again, back in core stage topping on the liquid hydrogen tank. And the update on the range. The range safety officer reporting to the NASA test director that the problem they had with access to the data from their radar site was a bad Ethernet switch. Again, the problem with the radar was actually a bad Ethernet switch, and the range is currently working to change it out and re-verify it. Range reporting that it should take about 70 minutes to perform that work. This is Artemis Launch Control. T-minus 42 minutes and counting. Got an update now on the liquid hydrogen loading operation. The upper stage is now in fast fill. Again, the upper stage of the rocket is now in liquid hydrogen fast fill, currently at 58% filled, while the core stage liquid hydrogen is in replenish. Again, the core stage liquid hydrogen is in replenish. On the liquid oxygen side, both core stage and upper stage are in stable replenish. Update on the range. The range informed the NASA test director that they will need to take a little bit longer to verify the replacement of an Ethernet switch, which cut out data that they were receiving from a radar site. We're looking at about 50 minutes left in work that the range is doing to replace that Ethernet switch. This is Artemis Launch Control. Yeah, we've had a couple of issues that the launch team has been working, and we have an update on both of those. First of all, is the leak, the liquid hydrogen leak in the replenish valve out at the mobile launcher. We understand from the launch team that that leak has not recurred. The work that happened out at the pad is that the red crew and the work that they did out there remedied the leak. That's good news. And now the liquid hydrogen tank on the core stage is back in replenish at this moment. And the upper stage of the rocket, liquid hydrogen side, is in fast fill. You can see from the graphic there that we are back up to 100% over on the liquid hydrogen side on the right hand of the screen. On the left hand of the screen, you can see we have been in stable replenish for liquid oxygen. Now, with regards to the range, they reported that they had an issue to the NASA test director with their radar sight. Later found out that that was actually a bad Ethernet switch that was cutting out and not providing them the data. The range reported that they will swap out that bad switch, and they're currently working on that. They advised at the time, about a half hour ago, that it would take them about 70 minutes, or about 25 minutes into that work. They did just recently update the NASA test director to say that it's going to take them a little bit longer because they're going to need to re-verify this Ethernet equipment once they have it installed. Again, that work is ongoing, but at the moment, if we were launching right now, the range is no-go as a result of that bad Ethernet switch. The Dolly-Loo file, which helps steer the Space Launch System through the upper atmosphere, has been uploaded to the rocket, and so we're good to go there in terms of other configurations that are ongoing. But we are continuing to monitor communications of the launch team about holding to the top of the window, currently slated for 1:04 a.m. Eastern Time. But we do have 2 hours, and we have yet to see whether or not the launch team is going to be able to make enough adjustments in order to hit the top of that window. No slip yet, but we're monitoring their work, and we'll give you an update when we have it. Back to you, Megan. T-minus 14 minutes and counting. We have an update now on the upper stage of the Space Launch System. Currently at 75% filled. We're in fast fill for the upper stage, and currently it is 75% filled for liquid hydrogen. We're in stable replenish for the core stage, both liquid oxygen and liquid hydrogen. And that includes the liquid oxygen on the upper stage. Stand by, we're getting an update from the range on their issue. I'll be right back. Yeah, Megan, we actually have about 10 minutes before we go into a half-hour hold. That half-hour hold is part of the L clock, and what you see on your monitor right now, I believe, is the T clock. So in about 10 minutes, we'll hold for a half hour, and currently the launch team is trying to evaluate how much of a delay may result from some issues that we've been facing over the past hour. Just to recap those, we had a leak in a replenish valve on the mobile launcher that feeds into liquid hydrogen core stage tank. That's been resolved. The leak has been fixed, and we're moving forward. Currently, the upper stage of the rocket for liquid hydrogen is roughly 70 8% at the moment. So that is tracking. Progress continues there. The core stage has been topped off, and now both liquid oxygen and liquid hydrogen are 100%, along with the upper stage of the liquid hydrogen side of the equation. So we're just waiting on the complete tanking of the upper stage liquid hydrogen. Now, with regards to the range issue that we had, we just got an update from the range, the 45th Space Wing officer reporting in to the NASA test director that the Ethernet switch has been replaced. This problematic switch took down their ability to see radar from one of their assets, which is key in getting acquisition and signal for the flight termination system if it were to be needed. Of course, this is a critical system that has to be tested before we can launch. So at the moment, we're looking still at a 1:04 a.m. Eastern Time launch, but it is pretty clear from the work that is ahead that it looks like we're going to slip into that window. How much exactly, we don't have an accurate calculation from the launch team as of right now. But of course, we're anticipating that. So for the moment, you see on your clock now, we are in the T-minus 10-minute hold. We just entered that. And now, roughly, we're looking at 28 minutes to resume terminal count. The launch team will assess what work needs to be done, how that syncs up with the range getting back online with their equipment, and then we should have a new T0 for you soon. That's the latest from Firing Room 1 here at the Kennedy Space Center. Megan, back to you. T-minus 10 minutes and holding. Got an update from the range to the NASA test director that their work on the bad Ethernet switch is complete and they are ready for open loop tests. This tests the range ability to send a destruct signal to the rocket in the case it were to go off course and endanger the public. This is a mandatory test that needs to be completed. Again, the range finishing the work on the replacement of their Ethernet switch that was rendered their radar acquisition and sending of the flight termination signal to the SLS rocket repaired. And so now they need to run an open loop test to confirm that they have good signal going into the rocket in case they need to send a flight termination signal. For the upper stage of the rocket, we are, well, let's talk about the whole rocket. Core stage and upper stage. We have the core stage in stable replenish, both hydrogen and oxygen. And in the upper stage, we're stable on the liquid oxygen side. We briefly paused fast fill on the upper stage, which is currently at 80% filled, in order to do a test of the vent valve on that liquid hydrogen tank. Fast fill has resumed, and currently we are in topping on the upper stage of liquid hydrogen. So that is just in. We are into topping on the upper stage of the liquid hydrogen tank, and we are awaiting the range testing their flight termination system with the launch team. This is Artemis Launch Control. We are currently in a T-minus 10 hold. This is a pre-planned hold that has 11 minutes left. The pre-planned hold goes for a half hour. The T0 is set for 1:04 a.m. Eastern Time, but currently the launch team is working to catch up to what appears to be a slip into the launch window, which is currently 2 hours and goes until 3:04 a.m. Eastern Time. Now we'll get a solid T0 once the launch team is able to determine how much work is left. But again, it's based on the math and where we are, it looks like we are slipping into the window. But again, that's not official. We don't have a new T0 as of right now. This is Artemis Launch Control. Yeah, that's right, Megan. So we are clearly in a delay now. The NASA test director, who's basically flying the ship for the launch countdown tonight, has said that we are extending the hold that we were currently in at T-minus 10 minutes and counting. And so that puts us off the 1:04 a.m. Eastern Time launch. We're now slipping indefinitely into the hold. NASA test director Carlos Monge saying that we are currently estimating how much work needs to be done before resuming the polling that is supposed to take place 15 minutes before launch. It then goes to terminal count at T-minus 10 minutes. Now we've got an update on the tanking of the upper stage liquid hydrogen tank. Currently 95% filled. We're in topping on that tank. It is the last of 4 tanks in the Space Launch System that needed to be completely fueled up before we launch. Of course, cryogenic tanking, a complex operation that has seen some delays tonight. We had a roughly hour delay after a replenish valve on the core stage liquid hydrogen side required hands-on work by a Red Crew team that went out to the launch pad and tightened down some bolts on the valve and got it fixed before leaving the launch pad, and then launch team verifying that that work was complete. Now currently we're awaiting some work with the range. The 45th Space Wing, which oversees the range here and makes sure that the airspace and the ocean out over the flight path is clear, and also has the responsibility to destruct the rocket should it go off track. They have been working on some issues with their equipment and sending a flight termination signal to the rocket. There is testing that must happen with the flight termination system that was delayed by a bad Ethernet switch. Switch has been changed out, and now the range is looking to start testing their connectivity to the rocket in order to preserve that safety function that they are responsible for. So again, we are slipping now indefinitely into the launch window. We're awaiting the launch team to evaluate just how much time is required to complete the work to get this rocket ready to launch. And of course, when we have a new T0 for you, we'll report that out right away. Megan, back to you. T-minus 10 minutes and holding. I have an update on a new issue that the launch team was studying, and that's the possible liberation, as they say, of some RTV, room temperature vulcanization, essentially caulk that is around the Orion, between Orion and panels that come off to reveal the solar panels for the Orion and European service module. The problem is essentially this: the caulk has a sensor in it, and it through camera inspections of the rocket, they have been able to determine that it is loose and could potentially come off. This is the same issue that was brought before a mission management team, which evaluates additional risks to the rocket, just a day ago. This happened after Hurricane Nicole passed through and delaminated some of the caulk around the bottom of Orion that connects to those panels. The team has determined that this caulk that encompasses this sensor on Orion is likely to come off after launch. And so the engineering team went and did a full analysis on what that debris trajectory could be once it comes off, and they evaluated that it falls within the same amount of risk that was evaluated by the mission management team a day ago. And so with no additional risk, that constraint has been removed. The engineers going on further to say that the RTV, as was discussed a day ago, is a loose and pliable material that is unlikely to cause a higher risk due to damage. They say it's likely to hit the LVSA, which is the adapter, the cone-shaped adapter that meets Orion and comes down, and the ICPS, and then comes down to the core stage. It is a rigid structure that would be able to withstand the impact of that RTV. So that constraint was just removed after discussion between engineers and the NASA test director, launch director, and mission management chair Mike Serafin. And so now we continue on. We are slipping into the launch window. Currently 9 minutes into the launch window, which ends at 3:04 a.m. Eastern Time. The team is currently evaluating the work they have left to do and how much time it will take them to complete it before they can start polling for go. That would normally happen 15 minutes before launch, and we are not ready to resume that polling at this moment. And so we are going into the window. The question is, how deep are we going into the window? A rough calculation of the work, and this is a rough calculation just for the benefit of those who are watching and those who are here to watch the launch, is no earlier than 1:45 a.m. That again is a rough estimation. This work has to be evaluated, calculated, and a new T0 given, and currently at this moment we don't have that. Just want to be real clear about that. The issue with the range and their radar asset, that has been fixed, and we are awaiting verification of their testing, which is part of the flight termination system, a critical safety system that allows the 45th Space Wing to send a destruct signal to the rocket should it go in the wrong direction. That test has not happened, and although the rocket is fully tanked, both core stage and upper stage, there's still some work to do to get it completely configured and ready to go. That's the latest. This is Artemis Launch Control. Yeah, Megan, thank you. And a clearer picture is starting to emerge as the launch team now reports out that they only have a few minutes left of work to do before they're ready to pick up polling. And we're also hearing that some of that polling, which kicks off with the mission management team, is also now just about 3.5 minutes away. Now, we are currently still in that hold. But the launch team, NASA's test director, is continuing to move the team forward. We've wrapped up work on the upper stage and the lower stage. You're looking now live inside Firing Room 1, where Launch Director Charlie Blackwell Thompson is overseeing her launch team. We've had a number of delays that have put us off the T0, but we are starting to track to a T0 close to around a quarter till, top of the hour. But we do need to have some polling that takes place. I'm pausing now because I'm listening in to the teams as they communicate. In this launch window, which we're currently 26 minutes into, and it's 2 hours long, it runs until 3:04 a.m. Eastern Time, we have what's called 40 cutouts. And in those cutouts, they range from about a second to about a minute. These are times where they can't launch. These cutouts must be accounted for when determining a new T0. The upper stage of the rocket, which was the last to get ready and configured, just recently the team cycled the liquid hydrogen valves, which is required, and they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done. We are now 1.5 minutes away from the poll of the mission management team, which is several minutes before T-minus 15 minutes. When that poll starts, we'll get a clearer picture of our T0. NASA's test director has informed the launch team to all switch to a common communication channel. It's called 232. And what this means is that the entire launch team is now on one channel, and all future communication will happen there. Whereas there are many channels. Now they reduce it down to one. Just heard from NASA test director Carlos Monge. I'm sorry, Jeff Spaulding. Jeff Spaulding's on. They swapped out. There are currently no constraints to launch. Great news. Again, no constraints to launch, and they're getting ready to pick up with a poll to determine readiness for launch. Okay, NASA Test Director Jeff Spaulding getting ready to conduct the readiness poll, so we are getting close. We're going to pull up the audio now so that you can listen in.
Rockets go.
All right, copy all. And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll. And attention on 232, this is the Launch Director performing the final poll for launch. Verify no constraints and go for launch. EGS Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS, Orion, and EGS CSOs have no constraints and are go for launch.
Copy, John. Thank you. Range weather.
Weather has no constraints and weather is go for launch.
Copy LWO. And Mission Manager. And Mission Manager, Launch Director.
Launch Director, Mission Manager on 232. The mission management team has been polled. You have a go to proceed with terminal count and launch of Artemis I.
I copy all. Thank you. And NTD, Launch Director.
Go ahead, Launch Director.
Yes, sir. On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis I.
Copy, Launch Director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD.
CVSC here.
Initiate recording of Orion cameras at this time.
In work.
R, NTD.
RSR here.
Perform the booster ignition SNA arm rotation enable.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from Launch
All right,
Director.
and all personnel, we are going to resume the clock here momentarily.
Getting ready to get that new T0 time. The poll that you heard was the NASA Test Director's poll. And
all right, and we have verified no cutouts at this time. And all personnel, we are going to resume the clock. GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark. 3, 2, 1, mark. GLS mainline has been initiated.
okay,
T-minus 10 minutes and counting.
we are T-minus 10 minutes away from liftoff of Artemis I. As you can see, the clock is now moving. Let's put that up. T-minus 9 minutes and 47 seconds. The L-minus 15 poll complete.
Show
It went
06:47:44 is the new liftoff time.
Affirm.
Okay.
Oh 01:47:44, 1:47 a.m. Eastern Time and 44 seconds. We went straight into terminal count. Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the Ground Launch Sequencer, a computer and software that is doing all of the commanding and monitoring of the Space Launch System. We'll hear callouts from the GLS operator, Alex Pandalos. as well as NASA Test Director Jeff Spaulding. GLS is pre-tensioning the umbilicals at this very moment. You can see them as they run down the rocket. That's getting them ready to detach. At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction. T-minus 8 minutes and counting. The GLS is performing up to 100 commands per second, including configuring ground systems for power transfer to the rocket. GLS is turning on cameras, recording video inside and outside the crew module to collect data for engineers. Purging the aft skirt booster with high flow nitrogen. Clear out any hydrogen gas that may be there. You can see the crew access arm is already retracted. When there is crew during Artemis II, it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff. I want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system will flood the mobile launcher with water. You'll see that sequence start at T-minus 17 seconds. Now coming up in less than 30 seconds, the ground launch sequencer will start bringing the high energy systems online, starting with core stage pressurization. Firing room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing. The liquid oxygen tank will come a little later. Now we're arming the Orion Ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
GLS is go for FTS arm.
The flight termination system is now armed. Coming up at 4 minutes and 40 seconds, a big moment. This is where the RS-25 engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Good word, we've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds. Up next, GLS fires up the KPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit Start.
GLS is go for core stage APU start.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage. At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
GLS is go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels. Coming up in 15 seconds, look for that thrust vector control actuator test. Engines will gimbal. And there they go. The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space. They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. Altogether with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power. So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power. The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
GLS is go for core stage to internal power.
The rocket's core stage, which houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket. But the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS, go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
10.
Hydrogen
GLS,
burn-off
go for core
igniters
stage engine
initiated.
start.
7, 6, 5. Core stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis I. We rise together back to the moon and beyond.
Engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis I. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis I. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated, these 177-foot boosters. Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. 2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15-foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis I, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members, we just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange. We're 4 minutes and 16 seconds into the flight of Artemis I. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis I, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good. Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now 5 minutes and 11 seconds into the flight, 7,656 miles per hour. Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight. Five minutes and 42 seconds into the mission, we are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center. Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis I, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight. About a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire at maximum thrust. Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control, Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down. "30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down. Now 7 minutes 45 seconds into the flight, traveling over 16,000 miles per hour. Continuing to hear good calls here in Mission Control, Houston. We're standing by for core stage main engine cutoff. And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The flight dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it. 35:45 now. Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring the Artemis I mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern Time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space. So solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide power to the spacecraft on its journey to distant retrograde orbit and all the way back to Earth. Once these are properly configured, again, Orion will no longer need to rely solely on battery power. And we expect this to be done about 30 minutes after liftoff. Right now, we're 19 minutes since liftoff today. Orion is now traveling 17,175 miles per hour. We're continuing to hear good calls here in Mission Control Houston from the flight controllers monitoring the mission. A little bit about these solar arrays as we wait. Again, we heard the call that the deploy has been initiated. We'll hear a little bit more about that once they start to unfold. These 4 solar arrays generate 11 kilowatts of power, which is enough electricity to power 2 3-bedroom houses, and they have a wingspan of 63 feet. Just one of these 6.5 by 6.5 foot panels has 1,250 solar cells. So you're looking at a total of 15,000 solar cells. Now, we just heard the call that all 4 solar arrays have been released. So we initially heard the initiation call. That command had been sent. Now those 4 solar arrays are released. Again, this is about a 12-minute process. These solar arrays will deploy straight, and you're getting a live view right now. This is really exciting. They'll eventually be swept back against the vehicle prior to translunar injection burn to prevent any loads from breaking or damaging the arrays. And on the end of each solar array is a camera that will capture imagery for us throughout the mission, along with a few other cameras placed outside and inside the spacecraft to help us monitor and perform various other inspections. Of course, if you recall the Apollo capsule design, there were no solar arrays. We had fuel cells instead. So this design with arrays gives us the opportunity to stay in orbit longer since we practically have no limit to the energy available for use from the sun. Coming up on 21 minutes since liftoff. Orion is attached to the interim cryogenic propulsion stage. You can see those 4 solar arrays unfolding now. And again, Artemis I is a flight test. It's paving the way for a sustainable presence at the moon. Looking forward to the future, Gateway will be our space station in lunar orbit. And we have some similarities and differences in the solar arrays unfolding right now on Orion and those that'll be on Gateway. So like we're seeing now, these are deploying autonomously. The Gateway solar arrays will as well. And while these generate those 11 kilowatts of power, the 2 rollout solar arrays, or ROSAs, on Gateway will generate 60 kilowatts of power. That ROSA design is currently being tested aboard the space station. We have 2 new ones installed and a spacewalk conducted earlier today, preparing for another set. Coming up on 22 minutes since liftoff today, Orion and the interim cryogenic propulsion stage traveling over 16,800 miles per hour. The solar arrays deploying now are part of the European Service Module. It's comprised of 20,000 parts and components. The Service Module was developed as part of an agreement between NASA and the European Space Agency, or ESA. This is the first time NASA is using a European-built system as a critical element to power an American spacecraft. Coming up now, and 24 minutes into the flight of Artemis I, spacecraft now traveling at 16,500 miles per hour around the Earth. We are in solar array deploy, and we have confirmation all 4 arrays are deployed. Coming up in a little less than 30 minutes is the perigee raise maneuver. And with our launch at 1:41 Eastern Time this morning, we are looking for a perigee raise maneuver about 53 minutes into today's flight. Again, we are now 25 minutes and 47 seconds into the flight, and we have a complete deployment of all 4 solar arrays. Orion's journey to the moon continues as planned. Again, looking forward to that perigee raise maneuver. That'll be coming up again at about 53 minutes into the mission, so about 27 minutes from now. During the perigee raise maneuver, the interim cryogenic propulsion stage will use its RL-10 engine to lift the lowest point of Orion in Earth's orbit. The current orbit is more of an oval shape than a perfect circle, and this burn will raise that point closest to Earth and make the orbit more circular. This will also include a checkout of Orion's systems and any adjustments to the solar arrays. It'll be a short burn, less than 30 seconds long, but critical to keep us on track, and it also prepares us for the next engine burn to send Orion to the moon. That's the translunar injection burn. That'll come up a little later, which is a longer burn, another firing of the RL-10 engine on the interim cryogenic propulsion stage. We caught a glimpse there of those solar arrays, and with all 4 solar arrays properly deployed, Orion's journey to the moon continues, and we've got more operational updates coming up shortly, but for now, I'm going to toss it back to Megan and Kayla at Kennedy. Thanks, Megan. And it has been a pretty smooth ride so far. And we are now, again, like you mentioned, coming up on 36 minutes since launch. That puts us about 17 minutes into the until the perigee raise maneuver. That's going to be the maneuver that lifts the lowest point of Orion's orbit around the Earth and puts us where we need to be ahead of the translunar injection burn. The translunar injection burn is that really long burn that we're going to need to send us on to the moon. So we've been treated to some exciting views from the spacecraft today, including, and we hope to see some from inside the cabin, but we expect to continue receiving photo updates throughout the mission. It takes a team, though, to bring the imagery of Orion down to Earth, so let's meet them.